Okay, let's look just at a couple more examples on how to use SOHCAHTOA to find side lengths. SOHCAHTOA, and we are supposed to find x, and we have the side length of 16. We also have been given the angle of 58 degrees, so we're just going to go ahead and start there. First of all, label our triangle. The hypotenuse is the side across from our right angle. Remember, the longest side. The opposite side, opposite from our angle of 58 degrees, is the side with side length of 16, and the adjacent side is the shortest side right here. We have been given the length of the opposite side, and we need to find the hypotenuse. We don't have the adjacent, so we can't use cosine or tangent. Let's set up our equation. The sine of 58 degrees is equal to the opposite, or in other words 16 over x. Oh, x is again in the denominator. That means we're going to have to divide something. But first we're going to solve our proportion. Sine of 58 degrees times x is equal to 16 times 1. And now divide by the sine of 58 degrees on both sides. X is equal to 16 over the sine of 58 degrees. And using our calculator again, 16 divided by the sine of 58 degrees, close parentheses, enter, 18.8668. For these problems, we were always supposed to round to the nearest tenth with one decimal. So x is approximately 18.9. That's the side length of our hypotenuse. And just a quick check, 18.9 is more than the opposite side of 16, which is longer than the adjacent. Makes perfect sense. The hypotenuse is the longest side. In this last example, we're supposed to find both x and y, but don't fret, we're going to do it exactly the same way as we have been doing. So, TOA. The angle we have is 40 degrees, so let's label the longest side across from our right angle is the hypotenuse, and that has the length of x. The side opposite from angle 40 degrees is the side labeled y, and that leaves our adjacent next to our angle 40 degrees. That is the adjacent side. So for our x, we need the hypotenuse, we have the adjacent. That means we're going to use the cosine. The cosine of 40 degrees is equal to 8 over x. X in the denominator means we will divide eventually, solving our proportion. By cross multiplying, we got x times the cosine of 40 degrees is equal to 8. And here is where we divide by the cosine of 40 degrees on both sides. And x is equal to 8 over the cosine of 40 degrees. Our calculator says that 8 divided by the cosine of 40 degrees is 10.44 and so on. Rounding to the 10th, x is approximately 10.4. Next, we're supposed to find y. Y is the opposite side, and we still have the adjacent given, opposite and adjacent. That means that we need to use the tangent. The tangent of 40 degrees is equal to y over 8. And now y is in the numerator. That means all we do is multiply both sides by 8. So it cancels out. 8 times the tangent of 40 degrees is equal to y. And what does the calculator have to say to that? 8 times the tangent of 40 degrees. Enter 6.712 and so on. In other words, y is approximately 6.7. Okay, could we have found y a different way after we knew that the adjacent side was 8 units and the hypotenuse was 10.4 units long? Of course, we could have used the Pythagorean theorem, but this time we wanted to practice our trig ratios. And just remember, in math, many times there are more than one ways to get to the right answer. For your summary, I want you to compare and contrast finding side lengths using trig ratios to finding angle measures using trig ratios. All right, that's it for today, and I will see you in class.